Okay, so we've already talked about one of the driving forces for chemical reactions, and that is the formation of a solid. Well, that's in a double replacement reaction or a precipitation reaction. There's another form of a double replacement reaction that kind of gets its own category. It doesn't form a precipitate. What it does, it forms water, and water is a liquid. And those kind of reactions are called acid-base reactions. So, when liquid water forms from an acid-base reaction, it is also a driving force. So we have a solid and a liquid, and we're going to get later to gases. So acid-base reactions are very similar to double replacement. They're kind of a subcategory of their own. And they work the same way. The cations trade places, but instead of forming a solid, it always forms water. And the way you know that is you have to look at the reactants. So if you look at the reactants, if you may remember from doing nomenclature, one of the things I told you is if anything starts with an H, it is automatically an acid. First letter, not somewhere in the chemical structure, but the very first letter makes it an acid. And OH makes things a base. I'm not sure if I actually mentioned that or not, but I am now. The way it works is the cations trade places just like they do in double replacement, which means you're going to have the Na with the Cl and you're going to drop and swap. So that's still true, drop and swap, just like in double replacement. And you're going to have H1 plus with the OH 1 minus. Well, when I drop and swap, what I get is I get NaCl and I get H, and then I'm going to put the two of them together, water. And that is a liquid. Most often this thing will be aqueous. It will dissolve in water. So that's your equation. Predicting the products is pretty simple. Balancing it, if you count, it is balanced already, so it's all taken care of. All right, let me erase what's on here. Sorry. Okay, we'll do this one. Again, I want to point out, the reason this 2 is here is not because the H takes it with it. The 2 actually belongs to the sulfate and was dropped and swapped. So what's trading is the H and the Ca, not the H2. They are trading places. So I'm going to have the Ca with the SO4, and I'm going to drop and swap charges. And I'm going to have the H, which is just H1 plus, not that 2. Like I said, the 2 belongs to the sulfate. And it's going to go with OH, which has a charge of 1 minus. And again, that 2 belongs to the calcium. It was dropped and swapped. That's where they came from. So when you're done dropping and swapping and trading cations, you end up with these reduced to 1 to 1 and these reduced to 1 to 1. To balance it, though, you might notice that there are 2 plus 2, 4 hydrogens, so you need to put a 2 here. And if you do everything else balances properly. Okay, one more. Okay, again, this 3 does not belong to the hydrogen, it belongs to the phosphate. So what's going to trade is the H and the K. They're going to trade places. And you're going to have K1 plus with PO4, which has that 3 minus charge. Look it up on your the back of the periodic table, or just pull it from here. And then you're going to have the H, which is a 1 plus charge, never the 3. That 3 belonged to the phosphate, that 2 belonged to the sulfate, with OH 1 minus. Drop and swap here, you get H3PO4 plus KOH makes K3PO4, and, oops, stop that, go away. Go away, go away, go away. I guess we have to wait. And then when you drop and swap with the H and the OH, you get H2O. All right? So now balancing this, that's the most important thing, is get the formulas right first, then try to balance. And there are 3 Ks, so I need to put a 3 here and everything else will work out. One of the things that's kind of cool about acid-base is if you are comfortable with the idea of looking at polyatomic ions as one thing, you might notice that there is 1 OH and 1 H, and if you remember my product, I had 1 water. And here I have 2 OHs and 2 H's, and I ended up with 2 H2Os. And here, oh, I didn't balance the H's, sorry, balance that now. I have 3 H's and 1 OH, which means I need 3 of the OHs, and I end up making 3 waters. So that's kind of cool. If you can't do that, though, don't worry about it. It's not a big deal. All right, now here's where it gets hard. I'm giving you the words. And again, drop and swap first. Trade the cations, balance last. So hypochlorous acid tells me it comes from hypochlorite. Hypochlorite is ClO 1 minus with H1 plus. That's what the acid means. Calcium hydroxide, Ca 2 plus, OH in parentheses 1 minus. So I'm going to get HClO plus CaOH 2. And I want to point out something. If you don't have those parentheses around that OH, you will never be able to balance this. Never. Okay, very important to make sure you have those parentheses there. Now, to figure out the products, again, I recognize this as being an acid base. Acid and hydroxide makes acid base. So it tells me that I'm going to get water. And my other product is going to be the Ca with this guy. And I already know its charges. I don't even really need to necessarily write them down. But I know that the H and the OH are going to make the water. So the Ca and this are going to drop and swap. And you get that. To balance this, you need to put a 2 here. Oh, God, stop that. Go back. A 2 here. And a 2 here. All right? So, most important thing. Notice how little time I spent balancing. The most important thing is getting the formulas and predicting the product more than anything else. Okay? So sulfuric acid tells me it comes from sulfate. Sulfate is SO4, -2. Acid tells me H1 plus. That's a 1 plus. And then iron 3 is Fe3. And again, hydroxide in parentheses 1 minus. So when I drop and swap my reactants, I get H2SO4 and Fe parentheses OH parentheses 3. And again, if you forget those parentheses, you will never be able to balance this. Then my products, I recognize this as being acid base. Acid hydroxide means one of my products is automatically water. That's what happens when the H switches with the Fe and goes with OH. That means the Fe and the SO4 are going to combine. And when I drop and swap the Fe with the SO4, I get Fe2 parentheses SO4 parentheses 3. Now to balance this one's a little harder to balance. I got a lot of numbers going on. So I usually don't do the hydrogens and the oxygens until the very end. So I'm looking at this and I'm seeing 3 sulfates or 3 sulfurs, puts a 3 here. And I'm seeing 2 Fes, puts a 2 here. Now I have to do either the hydrogens or the oxygens. And you might notice oxygens here and here and here and here. I save oxygen for last because if it's all over the place, it's just a mess. So I have 6 plus 6 means a total of 12. Put a 6 there and you will find that the oxygens balance on their own.